Hi class, let's take a look at problem 6, which is another set of applications. And what they want on this one is the perimeter. Now remember that the perimeter is the entire distance around the object. So in this case, the formula that we're going to use is P is equal to 2L plus 2W. And I'm just going to say that this is W and this is L. And also notice that the final answer is going to have units. They didn't put units on this problem, so we're just going to be adding units. So let me write it here so we don't forget. And in terms of units, well, they could have been talking about centimeters, inches, meters, anything you can think of. So since they don't mention it, we have to add it at the end of the problem. So in this case, P is equal to 2 times L. This is 1 1/3 plus the values of 2 times 4 4/5. So what I'm going to do is I'll distribute the 2's, but let me first separate the mixed numbers. So this is 2 times 1 plus 1/3 plus 2 times 4 plus 4/5. And then we're going to be distributing out the 2's to each of the actual numbers inside of the parentheses. I'm using the distributive property. So we're going to end up with 2 plus 2/3 plus 8 plus 8/5. And at this point, let me combine the integers. And let me just move this to the side so that we fit the whole problem. So P is equal to 2 plus 8 is equal to 10 plus 2/3 plus 8/5. And let me combine the actual fractions so that LCD will be 15. I'm not going to combine the 10 here because your numbers are mixed numbers. So it'll just make it easier to express it as a mixed answer since that's how they're given the problems. So the first fraction multiplied times 5, then times 2 and times 2. So we're looking at P is equal to 10 plus 10 15ths plus 16 15ths. So P is equal to 10 plus, and this is going to give us, actually wait, I have an error. This should be times 3. Since we need a 15, so it'll be times 3 and times 3. Okay, so that changes the top of this one. So this is going to be 24 15ths. Or in this case, 34 15ths. And let me check to make sure there's no other errors. So LCD is 15. Okay, we're good. And then what I'm going to do here is express this number as a mixed number. So this is going to be technically if it's 2 and 4/15. So the actual evaluation leads us to the following. So we're looking at the values of P, which is equal to 10 plus technically 2 and 4/15. And then we could do another separation. This will be 10 plus 2 plus 4/15. Or P is equal to 12 plus 4/15. And in this case, this fraction doesn't reduce any further. So we technically have the perimeter as 12 and 4/15. Since this one is technically a application, we'll express it with a sentence. So in this case, the perimeter is P is equal to 12 and 4/15. And keep in mind that all of these problems will have units. They didn't put units on this one, so we have to specify units since technically they could be talking about centimeters, inches, or any other unit. That's actually it for this one. Let's move on to problem 7. Now, problem 7 just has us do a little bit of shading in order to remember that they're equivalent fractions. So notice that the actual first fraction it represents 2/3, since we have 3 pieces and then 2 are shaded. Now what they want us to do here is to shade the equivalent. So this is going to be this portion here all the way to here, and this is the equivalent portion. But in terms of the second graph, we're looking at 1, 2, 3, 4, 5, 6. So 6 plus 6 will be 12. So this will be 12. And notice that if you're shading, the equivalent fraction is going to be 1, 2, 3, 4, 5, 6, 7, 8. So we're looking at 8 12ths. So the visual representation, it's going to be the 2/3. It's equivalent to 8 12ths. Now let's take a look at the second one here. Okay, and we're looking at thirds again. So this is 1/3. It's going to be equivalent to, and let me count it, 1, 2, 3, 4. So 4 12ths. And notice that you don't really have to do the shading. You could have just multiplied top and bottom to make it a 12. So this one multiplied times 4, that will give you the 4. This one multiplied times times 4 as well. Sorry. Okay, let's take a look at the next one, and it's also 12 pieces. So this is going to be 1/4. So this is 1/4. And in terms of shading, this is going to be 1 piece, 2, and 3. And then we're still counting 12. 1, 2, 3, 4, 5, 6. So in this case, this is 12, but we're looking at 3 pieces. Okay, let's take a look at problem 4. And problem 4 deals with 3/4. And as we do the shading, well, we're going to be shading all of these pieces. And in terms of 12s, let me count them. We're going to end up with 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of these pieces. Okay, let's take a look at the last one. The last one, it's technically 1/2. And we don't have 12 pieces. So it's going to be this area here. Total number of pieces, I'm counting 1, 2, 3, 4, and another 4, it's going to be 8. So this will be 8 pieces, and the equivalent is going to be 4. Okay, that's it for this one. Let me double check them all to make sure that there's no errors. And remember that all they wanted you to do is do the shading, and then we'll count the pieces in order to visualize the equivalent fractions. Okay, we're good on all of them. Let's move on to the last portion. And in this case, problem 8 wants us to evaluate the surface area. And notice that we already have a formula. So in this case, the formula is given, and we're looking at the S formula. So I'm just going to rewrite the S formula. This is equal to 6 times the values of S to the second. Now, from the actual shape of the cube, all the sides have to be the same. So technically, that would be the values of s. So s is equal to 3 and 1/2. And this one does have units. So we're simply going to evaluate the formula. And in this case, let me rewrite it as s is equal to 6 times, and this will be 3 and 1/2 squared. And then let me just rewrite it as inches technically squared, since we're dealing with area. And just for this one, let me combine it as an improper fraction. So s is equal to 6 times 3 times 2 is 6 plus 1. This will be 7/2 squared, and then inches to the second. And what I'm trying to do here is the easiest way to evaluate, in this case, the formula. So let me rewrite it as s is equal to, this will be 6 times 7 squared divided times 2 to the second, and then inches squared. Or s is equal to 3 times 2 for the 6 times 7 squared divided by 2 times 2. And we can cancel a common factor. So we can cancel one of the 2's. And s is equal to 3 times technically 7 squared divided by a 2. And let me check to make sure that there's no errors. We're actually good. Let me move the problem here, since this one may end up being a little bit messy. So the values of s, this is equal to 3 times 7 times 7 is going to be 49 divided by 2. So that's going to be a 7. I'm getting 147 divided by 2. So s is equal to, and let me box that answer and check it again. So 27, you carry 2 out. And as we carry the division, this is going to be technically 73. So 73 and 1/2 inch squared. Okay, so let me write it as a sentence. In this case, the surface area is s is equal to 73.5 inches squared. So it did turn out to be a little bit messy, but not that bad. Also, the last portion, keep in mind that we are expressing that as a sentence, but that's actually it. And also the formula it's given for these problems. The reason that I express it back as a mixed number is because your original numbers are mixed numbers. So that's actually it for problem 8.